those ones who may not have access to internet so that they can view it later on. And those ones who will be watching this video on YouTube, please make sure that you subscribe to the channel and you get more updates. So they have said that to determine the length of a line of a 3-dimension, you must identify the plane containing the line. So the plane can be a triangle, a rectangle, or a parallelogram. So there we have, it can be a triangle, a rectangle, and this is a parallelogram. Some of you don't know what a parallelogram is. So this is a parallelogram and this is a rectangle. So there may be a line. Maybe this is a triangle and they are telling you to determine if this is O, then this is A, then this is B. So they are telling you to find the length of line AB. So you must know which kind of plane is this line on. Is it on a triangle? If it is on a triangle, then we are going to use this trigonometric Pythagoras theorem or trigonometric ratio. Okay, so now these figures that we are seeing here, these are the planes on which the line is likely to be. So it may be on a rectangle or it may be on a parallelogram. For instance, it can be here, this is A and this is B and this is the line. So you have to know on which plane is this line. So the line is on the parallelogram, and then you understand that the kind of plane you are dealing with is a parallelogram. So let us proceed to the example. So they are saying that the figure given is a cuboid whose dimensions are 6 centimeters, 8 centimeters, and 10 centimeters, and 10 centimeters. So we have the cuboid right there. The cuboid, its sides are, if I may zoom in very well here for you to see, we have the cuboid there. So it has sides 6 centimeters, 8 centimeters, and 10 centimeters, as you see in the notes and also in the diagram here. So they are telling you find the length of the line DG. Find the length of the line DG. Find the length of the line DG. So the length of the line that they are telling us to find is this line from D to G. If I may draw that using my blue pen, from D to G, that's the kind of line they are telling us to find. So let me draw that, and then you see, I make it a dotted line to separate it from other lines. Okay, so they are telling us to find the distance between D and G, or the length of the line between D and G, from D to G. So that is the line that is cutting from one point, one corner to another corner. It is passing in the middle of that cuboid. So it is passing from the middle of that cuboid. Please, if you have a funny background, you have sound in the background, please mute, and then we can hear each other very well. So this is the line. They are telling us to find its length. Now, for us to determine this line, we should know on which plane is this line on. On which plane is this line on? Line DG. On which plane is this line on? So, after noting the plane, so let us see, how do we get the plane? So when you see, this is D to G, and then I have H down here. So I have something inside here. I don't know whether you can see it, this triangle. Inside, you see that plane which is inside. That plane that is inside is in the form of one of the planes that we talked about. So it is in form of a triangle. The plane that I've just shaded where this line DG is. So DG is inside this plane. So there is this plane that I've shaded from D to G. So I draw a line from D to G, and then I know there is H down here. So I draw a line from H to D such that I have a triangle, such that I have a triangle. So I must connect H also to D to create a triangle, because we have to use a triangle to use this kind of these mathematics notations like Pythagoras theorem and trigonometric ratios. These are the ones that we are going to use. So I must first get a triangle inside, and on that triangle there must be that line. That line must be on that triangle which I've created. So for me to create that triangle, I have to draw a line from H to D such that now I form a triangle here inside that cuboid, and DG is found on that triangle that is formed inside. So the angle which is here, the angle which is there at the corner of H, at this point here, between this red line and this line here, the angle which is there is 90 degrees. It's 90 degrees. So now I've formed a triangle inside there, and this triangle is 90 degrees, because we know that this base, are you seeing this base? This base is the base CHED is at 90 degrees with the line HG. So if I draw a diagonal from D to H, when I do a diagonal from D to H, I'll be drawing that diagonal on this base. So that means that the line DH is on the base, D, C, H, and E. They are on the same, it is on this base. But the base is at 90 degrees with this line HD. So it means that this line DH is at 90 degrees with HG. So it means that the triangle now formed here is a right angled triangle. Now for me, I cannot find DH. I cannot find DH unless I know D. I cannot find DG rather unless I know DH. So for me to find DH, what am I going to do? Anyone who can tell me, how do we find DH? How do we find DH? Anyone who knows, put up your hand and I see you. How do we find DH? Show up your hands and I see you. Yes, Kayesu, I've seen you. So how do we find DH?
Teacher, DH, yeah? We use Pythagoras theory, and we get EH as 8 centimeters.
Okay, before you give me the value, Kayesu, thank you very much. Yes. Before you give me the value of DH, which triangle have you used to find DH?
Triangle DEH, right angle triangle.
You have used the triangle DEH. So we are going to use the triangle D. Thank you very much. We are going to use the triangle DEH to find the line DH. Okay, so let us do that and see. So let us do that. So let us proceed. So from here, let us see how we can get this line DH. So we are going to extract out this triangle DEH, that triangle on the base DEH. So I will draw it. Let me get another paper here and I'll show you. Okay. So I'm going to draw that triangle which is inside. So I'll first draw DE. I'm going to draw DE first. So I have DE. And this is now from D to E. This is the line. And I'm going to draw now EH. So there I have H. And now I'm going to join that line there. I'm going to join it here. So I have that. So when you look at the base here, this base here, each angle here is 90 degrees, 90 degrees. It is 90 degrees. So here I have 90 degrees at that point. Okay. So I'm going to put the value of EH and DH. So if this is CH and it is 10, so it means that if CH is 10, from C to H, if it is 10, so it means that also DE is also 10. So I'll write 10 centimeters there. And also, if let us take a closer look there. If this is 8, DC is 8, so it means that also EH is also 8. So I'll write 8 centimeters there. Okay. So now what I'm left with is I have to find the value of DH using Pythagoras theorem. So you can draw it like this, the way you see it in the diagram, or after knowing that this is a right angled triangle, you can draw it like how it is represented here in the notes. So if I decide to draw it like this, I can find the length DH by saying that DH squared equals to DE squared plus EH squared. So DH squared will be equal to DE, but DE is 10 centimeters, so 10 centimeters squared, then plus EH, which is 8 centimeters squared. Okay, now from there, what do I get? So DH squared will be equal to 100 plus 60 plus 64. And my DH is the square root of 164. The square root of 106. So here you take the square root on both sides, because when you add 100 plus this, you get 164. So if this was squared, you find the square root on both sides, and you have that. So it means that my DH is equal to, what's the answer? DH is equal to, from there,
12.8.
12.1, 12.8, 12.81, isn't it? 12.81 centimeters. So those ones have just come. The question is telling us to find the length from D to G, from D to G. For me to find the length from D to G, I have to create a right angled triangle inside this by drawing a line from D to H. From D to H. Are we together? When the line D to H, you form a right angled triangle inside here. Here at H, it is 90 degrees because the base, this base C, H, E, D, that base makes 90 degrees with this line here. So I draw a diagonal from D to H. That diagonal is part of the base. The diagonal here is part of the base. Now that diagonal is at 90 degrees with DH. That means that now this DGH is a right angled triangle. It's a right angled triangle. So I've obtained DH as 12 points, you got it as 12.81 centimeters. So here I have 12.81 centimeters. 12 point. That's what we have inside there. So now I have obtained this diagonal. Now I can find this BH. But I want to ask you, what is BH? What is BH?
6.
Okay, so it means that if this is 6, now I can draw this right angled triangle D, G, and H, and I use 12.81, and also I use 6, so that I can determine D, G. Okay, so that's what we are going to do. So from the diagram there, I'm going to draw the line, the right angled triangle. That right angled triangle, I don't know whether you can see it there. I'm going to draw it, and then you see. Okay, so have the right angled triangle there, and then you can draw it. I can draw it the way I see it in the question, or I can draw it like how a right angled triangle looks like. No problem with that. So I know this point is H, because that's where 90 degrees is. That is H. This is B. This is 6 centimeters, and this is D, and this is from DH is 12.81. So now we are going to use Pythagoras theorem and we find DG. So we shall say DG squared equals to, who can tell me? DG squared is equal to? Put up your hand if you know. DG squared is equal to? Esther, proceed.
H squared plus DH squared.
DH squared. So Esther, you are going to give us the answer. What is 12.81 squared?
164.0.1.
Okay, so 164, then plus 30, 36.
36.
Okay, so what do we get from there?
200.
We get 200. So
14 point.
So we find the square root of 2. So DG squared,
200.
we find the square root of 200. And DG becomes
14.1.
14.14 centimeters. Right. So let us check and see. Exactly, they got 14.14 centimeters. Any question? Question. These things seem to be very easy. Okay. Now.
Sure.
Yes. Yes.
Is it a must to put it to 2 decimal places?
Is it a must? No, it's not a must. It is not a must. So you can have 14.1, it is also correct. But if they specify 2 decimal places, then you leave it to 2 decimal places. Okay. All right. Any other question? Carol, do you have any question? Carol?
No.
Okay. Patricia, Carol, Freda, Treasure. You are welcome, you are welcome, you are welcome. So let us proceed. The next part is an exercise. It's an exercise, but to relieve trouble from you, I'm going to first do maybe let me do for you question. Let me do for you question 4. Are we together? Question 4. To find the length of a line BF. But since we have looked at the cuboid, this was a cuboid. Now I can do question. Let me do question 2, which is a pyramid, which is different from what we have looked at. So let me do question 2, which is a pyramid, and then you understand very well. Okay. So we are having a pyramid there, and they are saying that the figure below is a square base pyramid. Square base pyramid. Now when you look at this figure here, A, B, C, and D. That is the base. A, B, C, D. That is the base. Are we together? Yes. Do you know a square? What are the characteristics of a square? What are the features of a square or properties of a square? Who knows the properties of a square? A square? Put up your hands if you know. Yes, Cynthia? Cynthia, you cannot speak while muted. Yes?
A square has 4 sides equal.
A square has 4 sides equal. That is correct. So a square is made up of 4 sides equal. Who knows the other property of a square? Put up your hand if you know another property of a square. So all sides are equal. That is correct. A square has 4 sides equal. What else? The other thing, if you don't know, the other thing is that at the corners, this at the corners, A, B, C, and D, at those corners, A, B, C, and D, the angle between AB and BC is 90 degrees. Is 90 degrees. The angle in between is 90 degrees. And also the angle between BC and so at the corners we have 90 degrees. Are we together? You should also know that at the point or where they meet, we have 90 degrees between those dotted lines. There, between dotted lines, we have 90 degrees. So those are 3 properties that you must know. The sides are equivalent, they are equal. At the corners of that square is 90 degrees, and also at the center where the diagonals meet, they meet at 90 degrees. Okay, the form of symmetry is correct. Now they are telling us to find the length of the diagonals of the base. So that the length of the diagonals of the base. Which are the diagonals? The diagonals we have A, C, and B and D, BD, BD and SC. But these diagonals are the same because I've told you that if this is a square, all the sides are equal. So it means that it forms diagonals which are equal to each other. So SC is equal to BC. So if we find the length of SC, it will be the same length of BD. So let us see, how do we find the length of those diagonals? Okay, so I'm going to start by drawing the figure. So I draw the base. Okay, that is the base. Now the next thing is for me to draw the height. So I'm going to first do the diagonals. That's the next thing. I do the diagonals so that I know where the center is. So this is where the center is. Now, the next thing that I'm going to do is I must be able to draw. I'm going to draw the height. The height, so maybe up to there. Then I can draw this, yeah, and this one there. Then I can join this there and this. So that is the pyramid. So I know this is 6 centimeters. This is also 6 centimeters. Then this is A, this is B, this is C, and this is D. The sides of the pyramid are also equal. So this is 10 centimeters, and this is V. The vertex, the tip here is called the vertex. It's called the vertex, and it is at the tip there. So now what you know that the length VC, all these slanting sides VC, VB, VD, VA, they are equal. They are equal to each other. All of them are 10 centimeters. Now they are asking us to find the length of the diagonals of the base. So the length AC or the length DB. So for me to do that, I know that from A up to the center or here, from A up to the center is half of AC. In other words, at the diagonal, at the center here, the length AC is bisected into 2. So AO is equal to OC. The diagonal is bisected into 2 at the center O. So it means that AO is equal to OC. And also BO is equal to OB. So if AC was 10, then it means that this will be 10 over 2 and 10 over 2. Are we together, members?
Yes.
Okay, so at here, it means that at this point, AO is half of AC, and also OC is half of AC. So this is half, this is half, this is half, this is half. Now, what I'm going to do is I'm going to use only one triangle. So there are very many triangles which are here. We have a triangle OC and V. You know whether you are seeing that OCV. There's that triangle here, and at this point, the height VO makes 90 degrees with the diagonal. So this height VO makes 90 degrees with the diagonal there. And also this height makes 90 degrees with all those other diagonals. 90 degrees, even there, 90 degrees, even here, 90 degrees. So it is 90 degrees. So it means that I have right-angled triangles. I have a right-angled triangle, VOC. I have another one, VOB. I have another one, VOA, and also another one, VOD. All these ones, all these. Now, like this one, which I'm shading, that is a right-angled triangle. At center O, it is at right angles. Members, are we together?
Yes.
Okay.
Yes.
Very good. It's a right angle. So you should know that. Now, let us come back. They are telling us to find SC. So for us to find the SC, we shall use a triangle ABC, because at this point is 90 degrees ABC. So we are going to extract out that triangle ABC, and we use that. So we shall not use this one. We shall use this one when we are finding the height. Are we together? When we are finding the height, we shall use VOC. But when we are finding the diagonal, let us use A, B, and C. Okay. So I will draw it the way it is, the way it appears. Okay. So this is A, this is B, and this is C. They are 90 degrees. So this is 6 centimeters, and this is 6 centimeters. Okay. This is what makes this triangle to be 90 degrees. Now together. So we are going to use Pythagoras theorem, and we shall say AC squared equals to AB squared plus BC squared. So AC squared equals to 6 squared plus 6 squared. AC squared equals to 36 plus 36. So AC squared equals to 72. And now we can find the square root on both sides. Both sides. Like that. So AC equals to, give me the answer.
8.48.
8.49.
8.49.
8.49 centimeters. 8.49 centimeters. So that means SC, which is the diagonal, is 8.49 centimeters. So that SC is equal to B, which is 8.49 centimeters. So when we come back again, we shall look at the next question, part B, which is telling us to find the height of the pyramid. So you go back and then you click on the join button, and then you come back again.